Alright, so this here is the Chapter 4 test review for pre-calculus. So question 1 here says, determine whether the graph of x squared plus y squared equals 6 has symmetry in those 4 parts. Okay, so this is those 4 tests that I had you write down the one day. Notice the x-axis here. The x-axis, we plug a negative in for the letter y. So I got x squared plus, we're going to plug a negative in for the y. And then we simplify. What's a negative y squared? Negative times a negative makes a positive. So then you bring everything else down to that, revert back to my original. And it did. So since it did, for the x-axis, my answer for that one would be yes. Okay, and then I'm going to try the next one. So let's test if it is symmetric in the y-axis. So if I test the y-axis, I plug a negative in for my x. So negative x squared plus y squared equals 6. Negative x squared, negative times negative makes a positive. So x squared plus y squared equals 6. And did that match up to my original over here? And again it did, so therefore this is also a yes. Okay, third one here, the line y equals x. What do we do every single time when you do anything with the line y equals x? We switch the x and the y. So on my original problem here, it would then change into y squared. So this is replacing with a y, and this is replaced with an x. Y squared plus x squared equals 6. And since you can add 2 plus 3, and then you can flip the order and go 3 plus 2, I can add these in different orders. So I can just flip-flop by moving these around. And then did that match up to the original again? And it did. So then it's also symmetric over the line y equals x. Okay, and the fourth and final test is over the origin, and we do a negative for both. Okay, so I'm going to plug in a negative in for my x, and I'm going to plug a negative in for my y, and then when I do that, negative x squared would be an x squared here, plus a y squared equals a 6. And then did it match up to my original? And this did too. Okay, so therefore on this one, all 4 of those were symmetric. On the test, that won't happen. Some will be, some won't be. But again, just do those tests and that'll get you the answer. Alright, second thing on the test is I'm going to give you a problem. It'll be 4 points, 1 point for each problem. There'll be 3 points, so I got 3 coordinates here. 3 coordinates in each problem that you'll have to readjust and write the proper numbers for. And then you'll have to draw the line, and that'll be the 4th point, or 4/4 of a point for each one. So, 4 points on the test for something like this, and they're going to have 4 equations. We're going to have a bunch of different equations here. Okay, I'm going to rewrite these coordinates so that you guys on screen can see them. So this point right here is 1, 2. This coordinate right here is negative 2, 1. And this coordinate right here is a negative 4, negative 3. Okay, so first thing here is I got an equation. You can use that chart that I gave you over here. Okay. That chart right there. If it's on the outside, you change the y values and you do the same operation. If it's on the inside, you change the x's and you do the opposite. Okay, so let's come back over here. Okay, we'll try this here. So, where's this half located? It's on the outside, so what's changing? My y's. Maybe if you would write it down, that might help you too. I'm going to do the same thing that's happening here, so it's being multiplied by half. So I multiply by half. Okay, so I'm going to take every y value and multiply by a half. So if I got an x here and a y here, what is half of, and I'll go green now for my new one, half of my y value, half of 2 is 1. So my new coordinate is now 1 comma 1. You will have to write the coordinate out on the test. You'll have to write that out. Okay, let's go to this y value over here. What's half of a 1 right here? Half of 1 is half. So therefore my new coordinate is here. And that coordinate, notice the x value does not change. So the x value does not change here, but the y value did. So, actually right over here so you can see it. Okay, and then, what's half of my y value here? Half of -3 would be 1.5. So then that would land right here. So this coordinate goes to there, and then this coordinate stays -4, comma, -1.5, because that's half of 3. 1.5. Okay? And then you have to draw in your new figure. So then it still crosses here at 0. And then we go down. Okay? That would be this function right here. Next one here. So there's two things going on here. There's a negative on the outside. So on the outside, it's the y values that change. Okay, so I'm going to reflect because it's a negative. And since it's on the outside, it's the y's which go up and down. So up and down. Or you're going to multiply, if you think of it like that, you're going to multiply by every y value by a -1 because it's a -1 out in front there. And what is this -2 going to do for me? It's looking on the inside, which are my x's, and you do the opposite. So opposite of -2 would be I'm going to add 2. So every x is going to add 2 and every y is going to multiply by a -1. Okay, so then if I do this now, move everything out of the way and redo it. Okay, so on this problem here, I'm going to take every y value and multiply by -1. So my new coordinate here would be -1. My new x, or my, no x, not x, sorry, y. Try that one more time here. I'm going to multiply my y value by -1. So -2 here. Here I'd have a -1. And then here I'm going to have a +3. So I multiplied every y value by -1. And then here x values get to add 2. So therefore I'm going to add 2 to this x value, which puts me to 3. I'm going to add 2 to this x value, which puts me at 0. And I'm going to add 2 to this x value, which means it's going up 2. Sorry, not up 2. Right 2, because the x's are right 2. Okay, so -4 plus 2 would be -2. So this graph is reflecting up and down, and then it is shifting to the right too. Okay, so let's plot these 3 points and then check them out. So over 3, down 2, over 0, down 1, and over back 2 and up 3. And can you see how it reflected and then it's shifting to the right 2. Alright? And then those will be the 3 coordinates that you plot and mark. Alright, let's try the next one here. Okay, so where's the half located? On the inside, and the inside changes the x values. So therefore it's the x's that change. And you do the opposite. So the opposite of multiplying by half would be dividing by half. Well, mathematically we can't do that. So that's the same as multiplying by the reciprocal. So the reciprocal here would be 2 over 1 or 2. So all the x values are going to multiply by 2. So what's this x value here going to turn into if you multiply by 2? 2. The y doesn't change. I can mark that right now if I want. Okay. What is this x value here going to change into? If you double it, negative 4, the y value doesn't change. And what is this x value going to turn into here if you double it? Negative 8, and the y value does not change. And the y value doesn't change because there's nothing on the outside. Okay? So, therefore, I'm going to have a negative 8 over here. So negative 8 comma 3. This is negative 4 comma 1. And then we have that one. And then if you connect them, you can see it's horizontally stretching twice as big. Okay, and two more here. So, that's that one. Okay, so I'm going to ask myself, where are the numbers located here? So on this one, I'll go blue this time, switch it up. 2 is located on the outside, so my y values are going to be the ones that change. And I'm going to multiply, because it's the exact same operation for the y. So I'm going to multiply every y value by 2. And then for the x's, it's on the inside. So what is going to happen to all my x's? I'm going to do the opposite of that, which will be a minus 1. So if I look up here, every y value is doubled. So this coordinate here, y value doubled would be 4. X value minus 1. 1 minus 1 would be 0. Okay? And that would now be right here. So what happened there was, it got twice as big in both directions, and then it shifts left 1 unit. Okay, so now if I double this y value, 1 doubled would be 2. Okay, and the x value, I'm going to minus 1, so negative 2 minus 1 would be negative 3. So then back 3 up 2. Okay, and then here I've got my y value doubled would be negative 6. Okay, and the x value, if you minus 1, would be negative 5. Okay, so then negative 5, negative 6. Okay, and then if you connect them, there is my new graph. Okay, last one. Alright, last one here. So these symbols, which there'll be one of these on the test, one of the 4 will be an absolute value. Okay, so if one of the 4 are an absolute value, we're going to know what absolute value. Absolute values are always positive. So on this problem here, on the inside here, we got a negative 2. Okay, so on the inside we got a negative 2, inside are opposite. So inside is x's, so the x's are going to add 2 to every x. Okay, and then if you think about this, anything that was below the graph is now going to be above the graph. So we're going to move to the right 2, and then we're going to make everything positive. So if you can imagine that every point here is going to shift, we'll shift to the right 2 units. Okay, so everything's shifting right 2, and even this coordinate here where it's crossing negative 3 would shift on the x-axis here. If you think about it like this, so you got this graph, and what's the absolute values mean? Every y value that was negative is now positive. So this coordinate, my new coordinate down here, and you're going to have to find the coordinates, so this would be over 0, up 1, this would be over 3, up 2. Pretty much every x value you're adding 2. But then any y value, so this point here was negative 2 comma negative 3. Now with an absolute value, all the y values are positive because of the absolute value bars here and here. Okay, so then this here, instead of being a negative 3, is now negative 2 and positive 3. And then can you see how that would then reflect up? So this piece here is reflecting from the bottom up, and this is actually no longer there. So then your new coordinate, because you have to write that on the test, would be -2, comma, and then 3. Okay, and that would be the reflection with an absolute value. Nothing is below the x-axis, everything's above because it's positive. Alright, here's another problem that will be on the test. This is called a piecewise function. Okay, so when we're doing a piecewise function, we're going to have to graph this function. So when I graph it, I would just use my graphing calculator. And when I do this, I'm going to plug it in here. I'm going to plug in my 3 equations. If you want to do them separately, you can. If you want to do them at the same time, you can. So I have a 2x and a +2. And then my second equation is x squared minus 3, and then 2. Okay? And I'm going to graph it. Now, there's 3 equations up here, but if you look here, they gave me a domain on the right side here. If x is less than -1, if -1 is less than or equal to x, which is less than or equal to 3, or if x is greater than 3. Okay, so let's graph this. I'll show you how this is done here. So if I have a graph sheet of paper, okay, I'm going to bring that over here. If I can get it to shift here. There, I'm just going to cover that up so you can see the equation. Okay, so, and then we're going to at the end state the domain, the range, and the zeros. So we'll get to that at the end, but I'm going to graph this first. So my first equation is 2x plus 2. So if I look over here on my calculator, and you guys have colored ones, 2x plus 2 is the first line, and it's a regular linear function going through at 2. And it's the y1. If I go second table, it gives me all the coordinates to plot on my graph. Okay, now here's the one thing that we got, you notice here it says if x is less than -1. So I actually have a barrier, this is where we did those dotted lines before, at -1. And I also have a barrier at 3, so I draw barriers in for those spots so that I kind of know that's where the endpoints are going to be at. Okay? So now let's draw the first graph here. So I know that it starts at -1. So if I go to -1 in my y1, the first coordinate is at -1, comma 0. Now would this be an open dot? Oops. Would this be an open dot on this spot or a closed dot? And it would be open. So I'm going to go to my calculator here. It would be -1, 0. So I'm going to go back 1, up 0, and it's an open dot. Okay, and then if I want to keep going here, I can click the up arrow, and I got -2, -2. So -2, -2, and when that makes sense, the slope is up 2 over 1. This is up 2 over 1, so then I can actually do the opposite of that and just keep doing the slope of that line. And if you, so there's my first line. And if I wanted to, I wouldn't have to do that. I could just keep going up here and just keep marking the points. -5, 8, so -5, 8, yep, matched up perfectly. Alright, next one's the parabola of the x squared. So now if I look back at my equation, that's now my y2. Where is this showing? From -1 to 3. Okay, so I gotta mark every point from -1. So at -1, now I gotta skip this y1 because that's my line or my linear function. I'm going to my parabola or my quadratic. -1, comma, -2 is my point. So then -1, comma, -2, and that would be a closed dot here. Okay, and then you're just going to mark every coordinate after that. So then I'd go to 0, comma, -3. So 0, -3. And then I would go 1, comma, -2. So 1, comma, -2. And then I'm going to go down further, 2, comma, 1. So 2, 1. Okay, and then I'm going to fill in one more using my table, 3, comma, 6. So over 3 end up 6, and that is a closed dot. And then you see how this is that part of the parabola? Okay, so that's just pieces of the parabola, only showing between -1 and 3, nowhere else. Okay, so I've got 2 of the pieces done, I've got 1 more piece. And nice thing about that last one, if you go back to the graph, was it's just a straight line at 2. Okay, well where does that start at? It starts anything where x is greater than 3. So if you go to 3, anything to the right of 3 is where that line is, and it's an open dot. So we'd have an open dot here at 2, and then the line would go on forever, like that. When you go second table on your calculator, and you go to column 3, that's the third equation, and your y equals, it's all 2, so then the height doesn't change. So my x value could be 3, my y value is 2, and if you go to the x's and you keep going down, you go back over, height's still 2, so it's just 2 all the way across. Okay, so there's my piecewise defined function, and you'll have to do one of those on the test tomorrow. Okay? Find the domain, the range, and the zeros of the function. So the domain of the function are the x values that are true. Is there any x values? So if you drew a vertical line, okay, if I drew a vertical line here, are there any x's that don't show up? So if I keep going in this direction to the left, will it keep going downward and have an answer? And it does. Okay, so everything's true. Right here on the barrier, even though this is open, this one's closed, so that fills it in, so everything's working there, and then it's the same on this one. This one's closed and that one's open, but since that one's closed, it counts, and then everything going in this direction would go on forever. So therefore, this domain would be all real numbers. Okay, range. What are my range values? It's my y values. So does it go up forever and down forever? Well, I know it goes down forever because of this function right here going down forever. So if I had like a vertical or horizontal line, is there a spot where it stops? And you see how right here would be that spot? Anything above there is not showing. So where is this function showing? The range, it would be y has to be less than, and now since it's a closed dot, or equal to 6. Anything below 6 is where my function is showing. Okay, and then it says what are the zeros of the function? Well, this is an open dot, so it actually doesn't hit there, so that doesn't count. So the only one that would count would be this one. Now it didn't land nicely, did it? Okay, so since it did not land nicely, what I can do is I can take my calculator and I can calculate the zero of the function. Okay, I'm just going to get that, and that's the parabola, that's the middle one, so I'm going to get rid of the first one, and I'm going to get rid of the last one. I'm just going to have the parabola in there. Okay, and I want to calculate the zero here of the function. So I'm going to go second, calculate the zero, left bound, enter, go across to the other side, enter, and then guess. Okay, and so what is the zero of the function in this problem? 1.73 according to my calculator. Okay? And that would be how you do that one. Alright, next one here. So on the test there are 4 of these, 1 of each, and then, so there's an add, subtract, multiplication, and division of my original 2 functions. Okay? And remember when you add the functions, this x means nothing, so you don't have to worry about that. It just tells me it's a function. So on the test, when I do this, it'd be the f function, which is x squared plus 2x. And then you're going to add that to the g function, which is x plus 2. So I have x squared plus 3x plus 2. Okay? Next one here is I have the f function minus the g function. So again, I'm going to keep my color coordination here. I'm going to have x squared plus 2x. Now here's the thing on the test you're going to have to remember. When you do minus, you have to put parentheses around the back side because it actually has to distribute into there. So if I distribute now, my final answer here would be x squared plus 2x minus x plus 2. combining like terms, I would get x squared plus 1x, or just x, and then plus 2. Okay, so the only thing you gotta remember on the test, maybe put a note when you're studying here, don't forget to put parentheses around this negative here. Okay? We'll keep rolling here. I'll move these down a little farther so we can see them. I'm going to slide down my page. Okay, so next one up is multiplication. Another line here. Okay, so if I'm going to multiply my functions, again you're going to have to remember to put parentheses around what you're multiplying. Okay, so I'm going to multiply the f function, which is x squared plus 2x, and the g function, which is x plus 2. Okay, so if I multiply these, you're going to FOIL. X times x, x squared times x gives me x cubed. The outside gives me a positive 2x squared. The inside gives me a positive 2x squared. And the last term gives me a plus 4x. And then you just combine like terms. So this is FOIL. X cubed plus 4x squared plus 4x. And there's no like terms, so I'm done. Okay, and the fourth and final one on this is going to be division. Now there's a trick on division that'll happen every time on the test, is you're probably going to have to factor and cancel either the top or the bottom. So when I do this here, I have x squared plus 2x. Okay, and then the g function is x plus 2. Okay, so now if I look at this f of x and g of x and I want to simplify, you cannot just cancel an x out because there's a couple x's above them because of the pluses and minuses. You have to factor. So what's common on the top? An x. And then after that, I would take out an x and I'm left with an x plus 2. And then on the bottom I have an x plus 2. Now do you notice if I put parentheses on the bottom, because I'm grouping the entire bottom, I now have something in common. It'll cancel on the test. So you got to factor and then cancel. So if you want to write a note here for that, it's factor, then cancel on the test. Okay? And my answer on this problem would be x. Okay? Alrighty, let's try the next problem here. So that's 4 points on the test. Here are 2 more. I'm probably not going to have something like this, but I will have these 2. So the f circle g of x and the g circle f, and you'll have to know which one is which. Okay, so when we're doing these, you got to know what these rewrite into. So this would rewrite into f parenthesis g parenthesis x. Okay, and this one would rewrite as g of f of x. Okay, so if I'm doing these, you always got to go from the inside out. So this is the g function on the inside, and I'm going to plug that into, you're always, whenever you have these circles, now they're not multiplication because they're not filled in. These ones are you sub it in or it goes into those functions. It's called the composite function. I'm going to take this function and plug it into the f function. So I'm going to take the g function here and plug it into the f function. Now there's 2 x's, so I've got to plug it in twice. Okay, so where that x is, I'm replacing the x with an x plus 2. And then it is squared here. And then there's a plus, and then there's a 2. And then I'm replacing that x again with an x plus 2. Okay? And then from this step, you just have to use math, your algebra, to simplify. Now when you square something I cannot distribute, what's a square mean? You take it times itself. Okay, I could distribute here though. So plus 2x and a plus 4. Okay, I have to FOIL this. So then x squared, outside is 2x, inside is 2x, and then the last is 4, And then if you don't use something, we bring it down. And then I just combine my like terms. So I get x squared plus 6x plus 8. And that would be my simplified function on that one. Okay, let's try the other one now. So now it's the f function here.